Welcome, and let the room grow soft and quiet around you. As your breathing slows, all on its own, imagine the ordinary yellow star that has warmed every morning of your life, hanging there above the world exactly as it always has. Tonight we are going to follow that star all the way to the end of its long story, across billions of gentle years, out past the day it swells and reddens and lets its outer layers drift quietly away into space, until nothing remains but a small white ember cooling slowly in the dark. There is nothing here to fear, and nothing at all you need to hold on to. Just breathe, and let go, and welcome back to Beyond the Stars. The first fact is that the sun is a star, an ordinary star, the very same kind of object as the small points of light scattered across your night sky. It only looks different to us because it is close. If you could lift the sun away and carry it out to the distance of the nearest other stars, it would shrink to a modest, unremarkable dot that no one would ever single out from the crowd. And if you could bring one of those distant stars here in its place, it would blaze exactly as our sun does. Nearness is the only thing that makes it special to our eyes. A very ordinary star, standing very close, warming a very small world. The second fact is that the sun is about 4.6 billion years old, formed from a slowly collapsing cloud of cold gas and dust adrift in the dark between the stars. Astronomers read that age in the oldest meteorites, small stones that never became part of any planet and have kept their original chemistry untouched ever since. That cloud hung there for ages, and then something disturbed it, and the middle of it began to fall inward under its own quiet weight. As it fell, it spun and it flattened and it grew hot at the center. The sun lit itself in the middle of that spinning disk, and everything left over became the planets. The Earth and the sun were born together, out of the same collapse, siblings, not strangers, and very nearly the same age. The third fact is that the sun is expected to shine much as it does now for something like 10 billion years in total, which means it has lived a little less than half of its long and calm middle age. Roughly 5 billion years remain before anything at all begins to change in a serious way. That is a span so vast that the entire history of life on Earth, from the first single cell in a warm sea to this very night, fits comfortably inside it with room to spare. Nothing about tonight is urgent. Nothing about this century is urgent. The sun has time, and rather a lot of it. And so, for now, do we. The fourth fact is that the sun holds 99.86% of all the mass in the solar system, which is a number worth resting with for a moment. If the whole solar system were weighed on one enormous balance, the planets would barely move the needle at all. Everything else, every planet and moon and asteroid and comet, all the rock and metal and ice that exists out here, adds up to barely 1/7 of 1% of the total. Jupiter alone accounts for most of that small remainder. The solar system is not really a family of worlds with a star among them. It is a star with a faint scattering of leftover crumbs still circling it, and we happen to live upon one of the crumbs. The fifth fact is that the sun is about 1,300,000 times the volume of the Earth, which means you could pour that many Earths inside it and still have room left over. Its diameter runs to roughly 1,390,000 kilometers, a little over 100 times the width of our planet. If the sun were the size of an ordinary front door, the Earth beside it would be a small coin lying on the step. And yet, among stars, it is quite average, neither a giant nor a true dwarf, simply a comfortable, middling star, exactly the size it needs to be. The sixth fact is that the sun sits about 150 million kilometers away from us, a distance astronomers call 1 astronomical unit and use as a measuring stick for the whole solar system. Light itself, the fastest thing there is, needs a little over 8 minutes to cross that gap. At that range, a jet airliner flying without ever stopping would need something close to 20 years to make the crossing. The Earth's orbit is very nearly a circle, so that distance changes only slightly through the year, which is one of the quiet reasons our climate has stayed gentle enough for life. We are neither near enough to scorch nor far enough to freeze, and we have held that comfortable middle place for billions of years. The seventh fact is that the visible surface of the Sun, the layer astronomers call the photosphere, sits at a temperature near 5,500 degrees Celsius. That is the warm yellow-white glow you see on any clear afternoon, though of course you should never look at it directly. It is not a solid surface at all, only the depth at which the gas finally becomes thin enough for light to slip free and fly out into space. Below that layer, the star simply grows denser and hotter without any boundary anywhere. The Sun has no shore, no crust, no place you could stand. Only a slow thickening of light into fire, all the way down. The eighth fact is that the Sun is made almost entirely of hydrogen and helium, the two simplest and oldest elements in the universe. Those proportions have shifted only slightly since the star was born, and only in the small hot region at its very center. Roughly 3/4 of it by mass is hydrogen, and almost all of the rest is helium, with only a faint trace of everything else, less than 2%, made of the carbon and oxygen and iron forged inside earlier generations of stars. Those traces are the ashes of stars that lived and died before ours was born. The Sun inherited them, and so did we, which is why the atoms in your hands are older than the star that has been warming them. The ninth fact is that the Sun is not solid, not liquid, and not quite an ordinary gas either, but a fourth state of matter that scientists call plasma. At such enormous temperatures, the atoms cannot hold onto their electrons, and so the whole star is a vast sea of bare nuclei and free electrons, drifting and swirling and carrying magnetic fields along with it wherever it flows. That is why the Sun can behave in ways no ball of ordinary gas ever could, twisting field lines into great loops and arches above its surface. It is a fluid of charged fire, and it moves the way weather moves, slowly and endlessly. The 10th fact is that the Sun rotates, but not all in one piece, which is one of the gentlest strangenesses about it. You can watch that difference yourself over a few weeks by following a single group of sunspots as it is carried slowly around the far side. Near its equator, it turns once in about 25 days, while near its poles it takes closer to 35. Being a fluid rather than a solid ball, it is perfectly free to turn at different speeds at different latitudes, and so it does. Over the years, this steadily wins and stretches its magnetic field, twisting it the way thread winds onto a spindle, until the field tangles and rearranges itself. That slow winding gives us sunspots and the 11-year cycle, a patient rhythm the Sun has kept for ages. The 11th fact is that the Sun is classified by astronomers as a G-type main sequence star, a yellow dwarf, which is a slightly misleading name for something so enormous. The word dwarf here simply sets it apart from the true giants, those swollen stars hundreds of times its width. Among the stars of our galaxy, the Sun is actually brighter and heavier than most, since the great majority of stars are small, cool red dwarfs that shine very faintly indeed. So it is average in the way a well-built house is average, unremarkable but sound. A perfectly ordinary star doing a perfectly ordinary thing very well. The 12th fact is that the light and warmth falling upon the Earth is only the tiniest sliver of everything the Sun sends out into space. All the sunlight that has ever fallen upon the Earth across its entire history is a rounding error in the Sun's accounts. Our planet is a small target at a very great distance, and it intercepts roughly 1 part in 2 billion of the Sun's total output. Every other part of that light streams outward past us, into the dark, on and on and on, forever. The Sun is not warming us in particular. It is simply shining in every direction at once, exactly as it always has, and we happen to be standing in a very thin slice of that light, and that slice has been quite enough for everything. The 13th fact is that the sun is far steadier than almost anything else in human experience, and that steadiness is the true foundation beneath everything alive. Its brightness varies by only about 0.1% across its whole 11-year cycle, a change so slight that no person would ever feel it. Over a single human lifetime, the sun's output is effectively a constant. Weather changes, seasons turn, empires rise and quietly pass away, and above all of it, that steady lamp holds almost perfectly still. Life could never have grown so slowly and so intricately beneath a flickering star, and ours has never once flickered. The 14th fact is that the sun is held together by a quiet and perfect balance between two opposing forces, a balance astronomers call hydrostatic equilibrium. Every star you have ever seen in the night sky is holding itself together in exactly that same quiet way. Gravity pulls every part of it inward, trying endlessly to crush the whole star down toward a point. The pressure of the hot gas and radiation inside pushes outward with exactly equal strength. Neither one ever wins. For billions of years, these two enormous tendencies have canceled one another out, at every depth, in every moment. The sun is not so much a fire as a truce, an argument between crushing and pushing that has stayed politely tied for 4.5 billion years. The 15th fact is that if the sun's inner furnace were somehow to fall silent this very instant, we would not notice for an extraordinarily long time. The heat stored within it lies so deep and leaks outward so slowly that the star would go on shining for tens of millions of years on warmth alone, dimming so gradually that no generation would ever mark the change. Nothing about the sun happens quickly. It is a slow, thick, patient object, and every process inside it unfolds across spans that dwarf the whole of human history. When we speak tonight of its death, we speak of something almost unimaginably gradual, a fading, never a snuffing out. The 16th fact is that the sun's surface is not smooth at all, but covered everywhere in granules, cells of rising and falling gas, each one roughly the size of a country. Astronomers can follow individual granules from one photograph to the next, watching them rise and spread and quietly vanish. Hot plasma wells up in the bright middle of every cell, spreads out across the top, cools, darkens, and sinks back down along the narrow lanes between them. Each granule lives only 8 or 10 minutes before dissolving and being replaced by another. And so the whole face of the sun is always simmering, always renewing itself. A slow boil of light spread across 1,000,000 kilometers. A great, quiet, unending shimmer. The 17th fact is that above the visible surface lies the corona, the sun's faint outer atmosphere, and it holds one of the loveliest puzzles in all of astronomy. It reaches temperatures of 1,000,000 degrees or more, hundreds of times hotter than the surface beneath it, and no one is entirely certain why the outer air of the sun should be so much hotter than the fire below. Magnetic waves and countless small reconnection events are the leading suspects. You can see the corona with your own eyes only during a total eclipse, when it appears as a pale silver crown, delicate, silent, and astonishingly hot. The 18th fact is that the sun is slowly losing mass all the time in two separate ways, and has been doing so since the day it first lit. You can see the solar wind whenever the northern lights appear, for those glowing curtains are made of particles from the sun caught in the Earth's magnetic field. It turns a little of its own substance directly into light and heat, and it also breathes out a constant thin stream of particles, the solar wind, which drifts past the Earth day and night at hundreds of kilometers each second. Together these come to millions of tons every second, which sounds enormous, and yet set against the sun's total weight it is barely a whisper. In 4.5 billion years, it has shed only the smallest fraction of itself. Hardly a breath. The 19th fact is that the Sun is, in a very real sense, an ordinary member of an enormous family, and that ordinariness is a comfort rather than any kind of disappointment. The Milky Way holds hundreds of billions of stars, and countless millions of them are close cousins of ours, similar in mass and temperature and age, doing exactly what our Sun is doing, in exactly the same unhurried way. Whatever happens to our star has already happened to billions of others, and will happen to billions more after us. It is not some strange fate lying in wait. It is simply what stars do everywhere all the time. The 20th fact is that everything we will speak of tonight has already been rehearsed over and over again, in every quarter of the sky. Every question about our star's future has already been answered somewhere out there, by a star that reached that chapter long before ours did. Astronomers have found stars at every stage of the story, young ones still settling into place, middle-aged ones like ours, swollen red giants, glowing shells of cast-off gas, and small white embers cooling quietly in the dark. We are not guessing at our Sun's future. We are simply reading it from the lives of its neighbors, the way you might learn the shape of a human life by looking slowly around a crowded room. And the story it tells is a calm one, and a very long one, with room enough in it for every dream you will have tonight. The 21st fact is that all of the Sun's light is made in a small region at its very center, the core, which fills only about the innermost quarter of its radius. Everything outside that core is simply an enormous blanket, wrapped layer upon layer around the furnace, holding the heat in and letting it out again very slowly indeed. The core is where the star actually lives. The rest is insulation and glow. When astronomers speak of the Sun running out of fuel, they mean only that small hot heart, deep in the middle, a furnace no wider than a fraction of the star that surrounds it. The 22nd fact is that the temperature at the center of the Sun is about 15 million Kelvin, which is nearly 3,000 times hotter than its own visible surface. At the very center, a single cubic centimeter of the Sun weighs more than a small stone, and yet behaves in every way like a gas. At such a heat, matter no longer behaves in any way that resembles ordinary experience. Atoms are stripped bare, nuclei fly about at tremendous speeds, and the density is greater than that of lead, though it is still a gas, held by the crushing weight of the whole star pressing down from above. That combination, enormous heat under enormous pressure, is the one condition in which starlight can be made, and the Sun has held it steady for ages. The 23rd fact is that the process making all of that light is nuclear fusion, in which the nuclei of light atoms are pressed so violently together that they merge into a heavier one. In the Sun, for nuclei of hydrogen are gradually welded into a single nucleus of helium. This is not burning in any ordinary sense. Nothing is consumed by oxygen. Nothing is set alight. It is a far deeper transformation, a change in the very identity of matter, happening quietly in the dark of the core. The Sun does not burn. It converts patiently one element into another. The 24th fact is that the helium nucleus that comes out of that merging weighs slightly less than the 4 hydrogen nuclei that went in, and that tiny missing sliver of mass is where all the light comes from. A single gram of that vanished mass would light a small town for years. About 0.7% of the mass simply vanishes and reappears as pure energy. This is the meaning of the most famous equation in physics, that mass and energy are two forms of the same thing. Every ray of sunlight that has ever fallen on your face was once a small piece of the substance of the Sun, transformed and set free. The 25th fact is that the Sun fuses about 600 million tons of hydrogen every single second, a figure so large it resists being pictured at all. That is a mountain range of hydrogen. gone in the time it takes to say the words. Of those 600 million tons, roughly 596 million tons emerge as helium, and about 4 million tons are converted entirely into energy and stream away as light and heat and neutrinos. 4 million tons of the sun becomes sunlight every second, and it has been doing this without pause for 4.5 billion years. The 26th fact is that the particular chain of reactions the sun uses is called the proton-proton chain, and the first step of it is astonishingly slow. It is one of the few places in nature where being extremely difficult is exactly what makes something last. Two protons must not only collide, but one must transform into a neutron at the very moment of contact. A change so improbable that any given proton in the sun's core waits, on average, billions of years for its turn. That extreme slowness is precisely why the sun lasts so long. If the reaction were easy, our star would have burned itself out in a moment. Its patience is the reason we are here. The 27th fact is that in spite of that enormous output, the sun's core actually produces energy quite gently, gram for gram. A given volume of the solar core generates less heat than the same volume of a compost heap quietly rotting in a garden. The sun is overwhelming not because it is fierce, but because it is unimaginably large, and so all those faint contributions add up. There is something rather lovely in that thought. The star that lights our entire world is, at heart, no more intense than a warm pile of leaves, simply repeated across a volume of 1 million Earths. The 28th fact is that the sun also regulates itself quietly and automatically, in a way that has kept it steady across billions of years. No engineer designed that balance, and nothing maintains it. It simply follows from the way heat and gravity behave together. If the core were to heat up slightly, it would expand a little, and expansion cools it, and the reactions would slow back down. If it cooled, it would contract, grow hotter, and speed up again. This gentle self-correction is called the stellar thermostat, and it is the reason our star does not flare and stutter. The sun holds itself in balance without any effort at all. A fire that quietly mines its own temperature. The 29th fact is that the energy made in the core does not simply fly out into space, but must first fight its way through the thick layers above, and that journey takes an extraordinarily long time. Immediately above the core lies the radiative zone, a region so dense that a packet of light can travel only a fraction of a centimeter before being absorbed by a particle and thrown out again in some random new direction. It moves like a person lost in a crowd, one step forward, two sideways, endlessly, and it makes almost no progress at all. The 30th fact is that because of this endless scattering, a single packet of energy needs something on the order of 100,000 years, and by some estimates far longer, to make its way from the core of the sun to its surface. If the light could travel straight out, it would leave the sun in about 2.5 seconds. A distance that light in open space would cross in about 2 seconds instead takes longer than our entire species has existed. The sunlight that warmed your face this afternoon began its life in the core before there were cities, before there was farming, before anyone had ever spoken a word, and it has been patiently working outward ever since. The 31st fact is that above the radiative zone lies the convective zone, the outer third of the sun, where the gas has cooled enough to become opaque and restless. Here light can no longer make progress on its own, and so the heat is carried instead by the bodily motion of the plasma itself, great columns of hot material rising, cooling at the top and sinking back down again. It is exactly what happens in a pot of water on a stove, only spread across 200,000 kilometers. The outer sun is a slow rolling boil, and its bubbles are the granules we see on the surface. The 32nd fact is that when a packet of energy finally reaches the photosphere and escapes into space, its long imprisonment ends in an instant. From that instant onward, Nothing will slow it or turn it aside unless it strikes something solid. After 100,000 years of being absorbed and re-emitted and turned about in the dark, it simply flies free and thereafter travels in a perfectly straight line at the speed of light, without hindrance, perhaps forever. Everything the sun has ever made either falls upon something or continues outward into the endless dark. The light that reaches your window has been waiting a very long time for its freedom, and it crossed the last stretch without pausing once. The 33rd fact is that the light leaving the sun's surface takes 8 minutes and 20 seconds to reach the Earth, crossing 150 million kilometers of empty space along the way. So the sun you see is always the sun of 8 minutes ago. Sunrise is a memory by the time it touches your eyes, and sunset happened before you watched it. There is a gentle strangeness in knowing that every daylight moment of your life has been a small message from the recent past, arriving faithfully, at the speed of light, 8 minutes and 20 seconds late. The 34th fact is that the sun also produces particles called neutrinos, which are so unwilling to interact with anything that they slip straight out of the core without being slowed at all. They pass through the Earth as easily as they pass through the entire body of the sun, arriving from below just as readily as from above. While light struggles outward for 100,000 years, a neutrino makes the same crossing in about 2 seconds, and then reaches the Earth 8 minutes later. Some 60 billion of them pass through every square centimeter of your body every second, day and night, and you feel nothing whatsoever. They are the only messengers that come to us directly from the heart of the sun, quiet, ghostly, and entirely harmless. The 35th fact is that those neutrinos gave astronomers their first genuine look inside the sun, and for a long time the numbers refused to agree. Detectors buried deep in mines counted only about a third as many as theory predicted, a discrepancy that troubled physicists for 30 years. The answer, found at last, was that neutrinos change type as they travel, and the early detectors could see only one kind. The sun had been perfectly honest all along. It was our instruments that were partly blind, and the mystery, when solved, taught us something new about the universe itself. The 36th fact is that the sun's output has a name and a measured value, about 3.8 times 10 to the power of 26 watts. A number that means very little until it is turned around. Even the tiniest fraction of that output, intercepted by one small planet, has been enough to lift oceans and grow forests for billions of years. In 1 second, the sun releases more energy than all of human civilization has used in its entire history, many times over. And it does this every second, quietly, without effort, without variation, and without any audience at all. Nothing is watching most of it. Nearly all of that light simply pours out into the empty dark, generous beyond any possible need. The 37th fact is that only a very small portion of the sun's total hydrogen is actually available as fuel, and that is the key to everything that follows tonight. Fusion happens only in the hot, dense core, and the sun does not stir its layers together, so the hydrogen in the outer regions can never fall inward to be used. The star will exhaust the hydrogen in its core while the great bulk of it, outside, remains almost untouched. The sun will die with most of its fuel still in hand, simply unable to reach it. The 38th fact is that as the sun fuses hydrogen into helium, the ash of that reaction quietly settles and stays where it is made, slowly filling the core. If you could look inside the sun tonight, you would find a sphere of helium at its center that simply was not there when the Earth was young. Helium is heavier than hydrogen, and it does not rise or drift away. And so, over billions of years, the very center of our star is gradually becoming a growing sphere of helium, packed ever more tightly, surrounded by the shrinking region where hydrogen fusion continues. The clock of the sun's life is written in that slow accumulation, a fire quietly burying itself in its own ashes. The 39th fact is that the process of fusion inside the sun is not only the source of our light and warmth, but the origin of very nearly all the energy that has ever moved anything on Earth. The wind blows because sunlight warms the air unevenly. Rain falls because sunlight lifts water from the sea. Plants grow, animals eat, coal and oil formed from ancient forests. All of it is sunlight held and passed along. Almost every calorie and every breeze traces back to that quiet furnace, 15 million degrees, 150 million kilometers away. The 40th fact is that when you lie in the warmth of an afternoon, or feel the last heat of the day still held in a wall, you are feeling the direct touch of nuclear fusion. It arrives without being asked, every morning, for everyone equally. The same process that has kept our star alight for billions of years is reaching gently across the emptiness to warm your skin. It has been doing so for every human being who has ever lived, and for every creature before them, without pause and without cost. There is nothing in all of nature more reliable, and it will go on being reliable long after this night, and every night has passed. The 41st fact is that the sun is not quite as steady as it seems, for across enormous spans of time it is very slowly growing brighter. The change is about 1% every 100 million years, which is far too gradual for any living thing to notice, and far too gradual to matter across any span that human beings care about. But over billions of years it accumulates, and it is the first quiet chapter in the long story of our star's ending. The sun is not dimming toward its death. It is very patiently warming toward it. The 42nd fact is that the reason for that slow brightening lies in the helium quietly gathering at the center of the star. It is a very slow feedback, running over hundreds of millions of years, and nothing in the star resists it. For hydrogen nuclei become one helium nucleus, which means the number of separate particles in the core keeps falling, and fewer particles produce less outward pressure for the same temperature. To hold itself up, the core must therefore contract very slightly and grow a little hotter, and a hotter core fuses faster and shines brighter. The sun brightens simply because it is succeeding at what it does. Its own ashes gently turn up the flame. The 43rd fact is that when the sun first began to shine, it was only about 70% as bright as it is today, which presents a rather beautiful puzzle. With so faint a star, the young Earth ought to have been frozen solid for its first 2 billion years, and yet the rocks tell us plainly that liquid water and living things were already here. Astronomers call this the faint young sun paradox, and the answer almost certainly lies in the early atmosphere, thick with gases that held the warmth in. The Earth kept itself comfortable while the sun was still finding its strength. A quiet cooperation very long ago. The 44th fact is that the Earth has been quietly compensating for the brightening sun for most of its life, through a slow chemical rhythm called the carbon-silicate cycle. It is a remarkable thing that a planet should be able to steady itself against a changing star, and yet the rocks record it plainly. When the world grows warmer, rain falls more heavily, rock weathers faster, and carbon dioxide is drawn out of the air and locked into stone, which cools things back down. When the world cools, the process slows and the carbon builds up again. Over hundreds of millions of years, this has held the surface within a narrow, hospitable band, even as the sun climbed steadily, a thermostat made of rain and rock. The 45th fact is that this quiet balancing cannot continue forever, because there is only so far the carbon in the air can be drawn down. Astronomers reckon that in something like 600 million years, the level will fall so low that the plants which use one particular pathway of photosynthesis will begin to struggle, and the great forests will slowly thin. It is one of the gentlest possible endings, a world growing quieter by degrees rather than by any catastrophe. Nothing about it happens in a day or a century or 100,000 years. It simply eases along over ages. The 46th fact is that the more meaningful milestone comes at roughly 1 billion years from now, when the sun will be about 10% brighter than it is tonight. The change would be so gradual that 100 generations could pass without anyone remarking upon it. At that level of warmth, the oceans begin to evaporate in earnest, and the water vapor in the air traps yet more heat, which lifts more vapor still. The seas rise into the sky as cloud and steam, and the earth becomes a hot, bright, humid world beneath a permanent white haze. It is very far away. 1 billion years is more than twice the time since the first animals appeared. An unimaginable stretch of quiet mornings between here and there. The 47th fact is that this means the end of life on Earth will come long before the end of the sun, and the two events are separated by billions of years. The oceans will be gone in roughly 1 billion years. The sun will not begin to swell for another 4 billion after that. By the time our star finally reaches out toward the inner planets, the Earth will have been a dry and silent world for longer than it was ever a living one. The sun does not destroy the biosphere by dying. It simply outlives it by a very great margin. The 48th fact is that even a small increase in the sun's warmth changes where the comfortable zone around it lies. The band astronomers call the habitable zone. Astronomers looking at other stars use exactly this idea when they judge whether a distant world might hold water. Today that band is a ring of space where liquid water can rest on a world's surface, and the Earth sits comfortably inside it. As the sun brightens, the whole ring drifts slowly outward, and eventually the Earth is left behind on its inner edge, while Mars finds itself within it. The zone is not fixed. It creeps outward across the ages, at a pace no eye could ever follow. A very slow tide of warmth. The 49th fact is that as that warm band moves outward, worlds that are frozen tonight will one day have their brief and unexpected season. Mars, cold and dry for billions of years, may find itself warm enough for liquid water once again as the sun grows stronger. Farther out, the icy moons of Jupiter and Saturn will soften. Europa, Enceladus, Titan, all of them held in deep freeze now, will feel the change. The outer solar system will have its long, slow spring, ages from now, exactly as the inner one fades. Nothing is lost, only moved. The 50th fact is that the Earth's own history has already given us a preview of a warming world. In the deep past, when the planet was far hotter than today, crocodiles and palms once lived within the Arctic Circle, and the world simply carried on. In the age of the dinosaurs, there was no ice at either pole, forests grew in the far north, and shallow seas covered much of the land. The world was warm, and it was full of life, and it lasted for a very long time. The Earth is more resilient than we sometimes fear. Its final change, when it comes, will not be sudden. It will simply be permanent and unimaginably far away. The 51st fact is that when the oceans do at last rise into the sky, the water will not stay with the Earth forever, though even its loss is a slow process. High in the atmosphere, sunlight breaks water molecules apart into hydrogen and oxygen, and hydrogen is light enough to drift away into space. Over hundreds of millions of years, the world's water thins into the dark, a little at a time. The seas will not boil away in a moment. They will simply gradually leave, the way a puddle leaves a warm stone only across an age. The 52nd fact is that the Earth will most likely end as a hot, dry, rocky world with a thick and heavy atmosphere, somewhat resembling Venus as it is today. From a great distance, it would look like a small, bright pearl, turning quietly where a blue world used to be. The surface will be far too warm for water, the sky will be white and dense, and the familiar blue and green will be entirely gone. And yet it will still be there, turning on its axis, circling the sun, marking out its days and years as faithfully as ever. The Earth does not vanish. It simply changes into something quieter. A still, warm world, going round and round in the light. The 53rd fact is that life itself may hold on far longer than the surface allows. Tucked away in places we scarcely think about, deep below the ground, in warm, wet rock kilometers down, there are microbes today that never see the sun and take their energy from chemistry alone. Such creatures could persist long after the last sea has gone, in the deep dark where the heat is gentler. Life on Earth may end not with a great silence, but with a very small and stubborn one. A whisper of living things beneath the stone, for ages after the surface has fallen quiet. The 54th fact is that we know the sun is brightening not from watching it, since the change is far too slow for that, but from understanding how stars work. The same equations describe stars we can watch at every stage, and they have never yet failed us. The physics of fusion and pressure and heat is well enough understood that the whole history of a star's brightness can be calculated from its mass and composition. And those calculations are checked against the sky, against thousands of stars of every age, and they agree. We are reading a forecast, not a guess. It is a very confident forecast, and it stretches billions of years in both directions. The 55th fact is that the timescales in all of this are so long that our ordinary words for the future begin to lose their meaning entirely. A billion years is roughly 200 times the span since the first city was built, multiplied again by 1,000. If the whole future of the Earth's habitability were laid out as a single day, all of recorded human history would occupy less than 1/100th of a single second. There is no urgency here of any kind. There is only depth and quiet and an almost unimaginable amount of time, more than enough for rest. The 56th fact is that between now and any of these changes, the sun will simply go on doing precisely what it does tonight, morning after morning, for hundreds of millions of years, 100 million ordinary years, one after another, each one indistinguishable from this one. It will rise and set and rise again. Seasons will turn. Rain will fall. The tides will come and go under the moon. Nothing in the coming 10 million years or the coming 100 million will look any different from an ordinary day. The story of the sun's ending is real, but it is not a story that begins soon. It is simply written far ahead in very small letters. The 57th fact is that even the very slow brightening we have been speaking of is not steady in the sense of being felt, for the sun will still hold its calm through every one of those years. A 1% change across 100 million years works out to a change so small in any human lifetime that no instrument could detect it against ordinary variation. If you could stand on the Earth 10 million years from now, the afternoon would feel exactly as it does today. The change is real and utterly invisible. A hand moving so slowly it seems perfectly still. The 58th fact is that there is a curious comfort in learning that the Earth's warm and living age is finite, because it makes the present moment rather more remarkable than it seemed. We happen to be living during the part of the story where everything works. We are here in the middle stretch when the sun is steady, the oceans are full, and the world is green. That condition has lasted for billions of years and will last for hundreds of millions more. And yet, it is not the permanent state of things. It is a long, generous season, and tonight falls comfortably in the warm middle of it. The 59th fact is that nothing described in this whole chapter of the story would ever arrive as an event, in the way we usually imagine endings. There would be no day on which the world changed, no year, no century. Every generation would find the world essentially as their parents had left it, for 100 million generations in a row. The sun's brightening is not a threat approaching. It is a slope so gentle that no one walking upon it could ever tell they were climbing, and we are only at the very beginning of it. The 60th fact is that all of this belongs to a future so distant that its only real effect on us tonight is to make the ordinary sunlight of today feel a little more precious. Nothing about the light coming through your window tomorrow morning will be any different from the light of 100 million years ago. The sun above your house is in the calmest, steadiest, most generous stretch of its entire existence, and so are you. There is nothing to be done about any of it, and nothing that needs doing. Let it simply sit in the back of your mind as a soft and distant fact. A star quietly brightening, far too slowly to disturb a single night's sleep. The 61st fact is that in roughly 5 billion years, the sun will finally exhaust the hydrogen in its core, and that is the true beginning of everything that follows. For 10 billion years, the core will have been quietly converting hydrogen into helium, and at last there will be no hydrogen left in that innermost region to convert. The reactions there will simply stop. It is not an explosion, not a failure, not a collapse. It is only a furnace that has finished its supply, and it happens so gradually that no single moment could ever be marked as the last. The 62nd fact is that this exhaustion has been approaching since the very first day the sun lit, and the star has spent its entire life walking slowly toward it. It has never rushed, and it has never paused, and it has never once been in any danger of stopping early. Every second of every year, 600 million tons of hydrogen have been leaving the fuel supply and joining the ash. There has never been a pause. And yet the reservoir is so vast that this steady drain will take 10 billion years to empty the core. Nothing in nature is more patient than a star spending itself. A fortune so large that even endless spending takes an age. The 63rd fact is that when the fusion in the core ceases, the outward pressure that has held the star up in that region disappears, and gravity, which never rests, finally has its way. The helium core begins to contract under its own weight, drawing inward, growing denser. This is not a violent fall, but a slow settling across millions of years. And here is the strange and lovely part, for as the core contracts, it does not cool. It grows hotter, because squeezing a star always makes it warmer, never colder. The 64th fact is that this rule that compression heats a star is one of the deepest and most surprising things about stellar life. It is the reason a dying star grows brighter instead of fainter, which surprises almost everyone who first hears it. A star behaves in a way opposite to almost everything else in ordinary experience. Take energy away from it and it shrinks and heats up. Give energy to it and it swells and cools. This is the reason a star can never quietly settle into a comfortable middle state once its fuel runs low. Every step it takes to save itself makes it hotter still, and each new heat unlocks a new kind of fire. The 65th fact is that as the helium core shrinks and warms, it pours that heat into the shell of hydrogen just above it, and that shell begins to fuse. The hydrogen there had always been too cool for fusion before, but with the core now pressing heat outward, it lights. And so the sun does not stop shining when its core is spent. Instead, the fire moves outward, into a thin burning layer wrapped around a dead center. The star is like a lamp whose wick has moved. The flame is simply somewhere new. The 66th fact is that this shell of burning hydrogen is actually hotter and more energetic than the old core ever was. And so the sun begins to shine more brightly than at any time in its history. A star that has begun to run out is, for a while, the most luminous version of itself it has ever been. Sitting on top of a contracting, heating core, the shell fuses hydrogen at a much faster rate. The luminosity of the star climbs steadily over the following hundreds of millions of years. The sun's decline begins with an increase. Its first response to running out of fuel is to burn harder, which is one of the quiet ironies of how stars die. The 67th fact is that this stage of a star's life is called the subgiant phase, and it is the gentle transition between the long, steady middle age and the great swelling to come. During this time, the sun will grow slowly larger and its surface will begin to cool, drifting from white-yellow toward a warmer amber. It will still be recognizably the sun, only bigger and softer in color, and considerably brighter. The whole subgiant stage occupies something like 500 million years, which is to say, it is a slow change wearing the mask of no change at all. The 68th fact is that the reason the sun grows larger rather than simply brighter has to do with how the extra energy from the shell must escape. The star grows because growing is the easiest way for it to let go of what it is making. A star must find some way to release everything it produces, and when the rate of production climbs, the outer layers respond by expanding, offering a much greater surface across which to let the heat go. A larger surface can shed the same energy at a lower temperature. So the sun swells and its surface cools, even while the star as a whole grows brighter. A paradox that holds together perfectly. The 69th fact is that the helium core at the center of the subgiant sun will not be fusing at all, and that is an important thing to hold on to. Helium requires far greater heat than hydrogen before its nuclei can be persuaded to merge, something like 100 million degrees rather than 15 million. Until that threshold is crossed, the helium simply sits there, inert and steadily compressing, growing hotter and denser but making nothing. It is a dead center inside a living star, waiting quite patiently for a temperature it has not yet reached. The 70th fact is that as the helium core contracts, it becomes so dense that its matter enters a strange condition physicists call degeneracy. Nothing in ordinary experience behaves this way, and yet it is perfectly common in the hearts of aging stars. The electrons within it are packed so tightly that a rule of quantum mechanics forbids them from being pressed any closer together. And it is this rule, rather than heat, that holds the core up. Degenerate matter is unlike anything on Earth. A teaspoon of it would weigh many tons. The heart of the aging sun becomes something entirely new, a substance held apart by the laws of the very small. The 71st fact is that this degenerate helium core will grow to something like a third of the sun's mass, all packed into a sphere not much larger than the Earth. Imagine a mass 100,000 times that of our planet compressed into roughly our planet's volume, and glowing white-hot at the center of a swollen star. That small dense object is, in every meaningful sense, an infant white dwarf. The end of the story is already forming inside the middle of it, the ember at the heart of the fire long before the fire goes out. The 72nd fact is that during the subgiant phase, the sun's brightness will rise until it is perhaps 2 or 3 times what it is tonight, and its diameter will roughly double. From a distance, the change would be so slight from one century to the next that no instrument could catch it. From the Earth, if anyone were there to see it, the sun would appear noticeably larger in the sky and would carry a warmer, more golden color. It would be a beautiful thing to look at, though the world beneath it would long since have lost its seas. A larger, gentler colored sun rising over a bright and silent planet. An extraordinary sight, with no one left to see it. The 73rd fact is that all of this unfolds so slowly that the very word transition begins to feel misleading. The subgiant phase alone lasts hundreds of millions of years, longer than the entire age of complex animal life on Earth. A civilization living through it would pass through millions of generations without any of them noticing a change in the sky. When astronomers describe a star as changing rapidly in this stage, they mean rapidly by the standards of stars, which is to say imperceptibly by every other standard there is. The 74th fact is that we can see this stage happening right now in other stars, which is how we know the shape of it so well. Every one of those stars is a snapshot of a moment our own sun has not yet reached. Subgiants are scattered across the sky, stars that have finished the hydrogen in their cores and are just beginning to swell. Astronomers plot the brightness and color of thousands of stars on a single chart, and the subgiants fill a well-defined region between the steady main sequence and the giants above. Our sun's future is drawn there in ink, a place on a diagram that it will slowly climb toward. The 75th fact is that the diagram in question is one of the great achievements of astronomy, and it was assembled independently by two people, Ejner Hertzsprung and Henry Norris Russell, in the early years of the 20th century. They simply plotted the brightness of stars against their color and found, to their surprise, that the stars did not fill the chart at random, but gathered into distinct bands and clumps. Those bands are the stages of stellar life. In one quiet picture, the whole biography of every star in the sky is written, including ours. The 76th fact is that when astronomers wish to know the age of a whole cluster of stars, they look for the exact point where its stars begin to leave the main sequence and turn toward the subgiant branch. A single photograph of a star cluster is therefore also a clock if you know how to read it. Heavier stars exhaust their cores first, so the turn-off point creeps steadily down the sequence as a cluster ages. Reading that point is like reading the hands of a clock. It is how we know that some star clusters in our galaxy are more than 12 billion years old, nearly as old as the universe itself. The 77th fact is that the sun's mass is the single thing that determines this entire story. From beginning to end, a star only slightly heavier would run through its hydrogen far faster and die in a fraction of the time, while a star only slightly lighter would linger for tens of billions of years. Mass sets the pressure, pressure sets the temperature, temperature sets the pace of fusion, and the pace of fusion sets the length of a life. Everything about the sun's future was decided in the moment it formed, written once in a single number. The 78th fact is that this makes the small red dwarf stars the true long-livers of the cosmos, and there is something rather touching about them. A red dwarf lit at the beginning of the universe would still have essentially all of its fuel remaining tonight. A red dwarf holds only a fraction of the sun's mass, burns its hydrogen with extraordinary thrift, and stirs its whole interior so that every last part of its fuel can be used. Such a star may shine steadily for trillions of years, far longer than the universe has yet existed. Not one of them, anywhere, has yet had time to die. Every red dwarf ever formed is still burning tonight. The 79th fact is that by the time the sun leaves the main sequence, the solar system will have changed a great deal in ways that have nothing to do with the star itself. The moon will have drifted considerably farther from the Earth, long since ending total eclipses. The continents will have gathered and split apart several more times. Whatever we are or were will be an unimaginably ancient memory. 5 billion years is a span in which everything familiar is rearranged many times over, and the sun, through all of it, will simply have gone on shining. The 80th fact is that the end of the sun's core hydrogen, when it comes, will be the quietest turning point imaginable, a moment nobody could witness even standing beside the star. A star does not announce such things. It simply carries on in a slightly different way than before. Deep in the middle, in a region no light escapes from directly, a reaction that has run for 10 billion years will simply taper into stillness. Above it, the shell will light, and the star will begin its long, slow swelling outward. There will be no sound and no flash, just a fire moving gently outward through a star, and the beginning of an ending that takes another billion years to unfold. The 81st fact is that after the subgiant phase, the sun will begin to climb what astronomers call the red giant branch, and its swelling will grow steadily more dramatic. The shell of burning hydrogen around the dead core pushes harder and harder against the layers above, and those layers respond by expanding enormously. Over a few 100 million years, the star inflates far beyond anything it has ever been. The sun will become a red giant, one of the most common and most beautiful stages in the life of a star, and one that fills the sky of every galaxy with warm amber light. The 82nd fact is that at the height of that phase, the sun will have swollen to something close to 100 times its present diameter, reaching out to roughly the distance of the Earth's orbit. If the Earth is still there at that moment, it will be resting at the very edge of the star that made it. One astronomical unit, 150 million kilometers, that gulf we have always thought of as vast, will become simply the surface of our own star. What is now empty space between us and the sun will be filled with the thin outer atmosphere of the sun itself, the distance quietly closing over ages until it is no distance at all. The 83rd fact is that in spite of growing so enormously large, the red giant sun will actually be cooler at its surface than it is tonight, perhaps 3,000 degrees rather than 5,500. That lower temperature is exactly why it turns red, since cooler things glow in longer, redder wavelengths. So the star that swells to swallow the inner planets will do so wearing a soft, deep, orange-red color, a great warm ember hanging in the sky, bigger and brighter overall, and yet gentler in every square meter of its surface. An enormous, tranquil, ruddy light. The 84th fact is that the total brightness of the red giant sun will be something on the order of 1,000 times what it is today, and possibly more at its peak. Even so, it would be an entirely ordinary red giant, quite indistinguishable from the many thousands we already know. All of that output pours from a surface so vast that the light per unit area is quite modest, but the sum is overwhelming. If the sun of that era were placed where it is now, the inner solar system would be flooded with light. From a great distance, our star would shine as one of the brighter points in the local sky, an ordinary star having its one brief season of splendor. The 85th fact is that the density of the red giant's outer layers will be almost unbelievably low, thinner than the best vacuum ever made in a laboratory on Earth. Spread the same mass across a volume 1,000,000 times larger and the gas becomes little more than a glowing haze. In truth, a red giant is mostly emptiness, a vast tenuous atmosphere surrounding a tiny dense core. If you could somehow pass through its outer regions, you would find them wispy and thin, more like a colored fog than a fire, enormous, and yet made almost entirely of nothing. The 86th fact is that Mercury, the innermost planet, will be swallowed early in this expansion, and it will happen without any drama at all. It would take millions of years, and there would be no moment anyone could point to as the end. As the sun's surface swells past its orbit, the little world will find itself moving through gas rather than vacuum, and that gas will drag on it, slowing it, letting it spiral gently inward. Mercury will not be shattered or burned in some sudden moment. It will simply be absorbed, dissolving quietly into the outer layers of the star, the first of the planets to return to where it came from. The 87th fact is that Venus will follow, in the same slow and unremarkable way, some time after Mercury has gone, a world nearly the size of our own, wrapped in its thick white clouds, will be enveloped and drawn inward and taken back into the substance of the sun. Everything that Venus ever was, its crushing atmosphere, its volcanic plains, its long, strange backward rotation, will be stirred back into the star, atom by atom. There is nothing violent in it. The sun simply reaches out, over millions of years, and gathers its nearest children home. The 88th fact is that this expansion, though enormous, is still gradual by any human reckoning, taking place across many millions of years. A star that swallows planets does so at a pace slower than the drifting of continents. The sun's surface will creep outward at a pace of perhaps a few kilometers per year on average, which is to say that a person standing on Mercury, if such a thing were possible, would see no change at all in 1,000 lifetimes. The swallowing of planets is not an event. It is a process so slow that the word swallowing gives entirely the wrong impression. A tide rising over an age, rather than a wave. The 89th fact is that we can see stars in exactly this condition all over our own sky, and some of them are among the most familiar and beautiful stars we know. Aldebaran, the warm orange eye of Taurus the bull, is a red giant. Arcturus, the bright amber star of the northern spring, is another. When you look at those stars on a clear evening, you are looking at our sun's own future, already on display, hanging quietly in the dark. A preview posted in the sky for anyone who cares to look up. The 90th fact is that the red giant phase, for all its drama, is quite short by stellar standards, lasting only a few 100 million years. The interesting parts of any star's biography are crowded into the final few pages. After 10 billion years of steady, unchanging life on the main sequence, the great swelling and reddening occupies perhaps 1 or 2% of the star's total existence. Almost all of a star's life is the calm part. The dramatic chapters are brief, and they come only at the very end. That is true of nearly every star in the sky. Long, quiet middles, and short, luminous conclusions. The 91st fact is that as the sun expands, it will also begin losing mass at a far greater rate, through a slow and steady wind blowing off its enormous surface. Gravity's grip on the outer layers of such a bloated star is very weak, since those layers sit so far from the center, and the pressure of the star's own light helps to push them away. And so the red giant sun will breathe out into space continually, shedding its substance in a soft outward stream, losing itself gently, the way steam leaves an open cup. The 92nd fact is that the color of a red giant is one of the loveliest things in astronomy, and it comes from simple physics that anyone can feel. It is a color everyone already knows, and has always found comforting. A cooling piece of iron glows white, then yellow, then orange, then deep red as it loses its heat. Stars do exactly the same thing. The red of a giant star is the red of a fading ember, the red of a hearth late at night, the red of the last light in a stove. Our sun will end its bright life wearing that same warm color, the color of banked coals, spread across half the sky. The 93rd fact is that although the red giant sun will be 1,000 times brighter, the intensity of its light on any nearby world would be strange and diffuse rather than piercing. The star would fill an enormous swath of the sky, no longer a small disk but a great looming presence covering much of the view, glowing softly and evenly. There would be no sharp shadows of the kind we know. The light would come from everywhere at once, soft and warm and red, more like standing inside a lantern than beneath a lamp. The 94th fact is that the interior of a red giant is a study in extremes held gently together, with a core the size of the Earth and an envelope the size of a planetary orbit. Almost all of what the star has ever been is gathered into a space you could hold in your imagination. Between those two regions is a smooth continuum of gas thinning outward across 100 million kilometers. Nearly all the mass sits in the tiny center. Nearly all the volume is in the vast, thin, cool outside. It is one object, and yet it holds two entirely different worlds inside itself. A dense white heart, and a colossal red breath around it. The 95th fact is that this stage will also stir the sun in a way it has never been stirred before, in a process astronomers call the first dredge-up. As the star swells, its convective outer layers reach much deeper than they ever could before, down toward regions where fusion once happened, and they bring processed material up to the surface. The composition of the star's visible face quietly changes. Elements made in the depths appear in the light. The sun will, for the first time, show us a little of what it has been making inside, very late and very briefly. The 96th fact is that red giants are so bright that astronomers use them as beacons, visible across enormous distances where sun-like stars would be far too faint to see. A star can be seen across intergalactic distances only in the brief season when it is dying. A single red giant in a distant galaxy can be picked out and measured, and the brightest of them serve as a rung on the ladder we use to measure the size of the universe. Our sun, in that far future, will be briefly bright enough to be noticed from other galaxies. A modest star, having one moment of being visible from very far away. The 97th fact is that despite the enormous swelling, the red giant sun would still be entirely silent. As everything in space is silent, there would be no roar to any of it, no crackle, no rush. The most dramatic transformation in the life of our star will unfold in perfect quiet, across 100 million years, in the vacuum where no sound can travel. All the fire and all the expansion, and not the faintest whisper of noise. The sun will grow to 100 times its size without making a single sound, as still as this room is now. The 98th fact is that a red giant is not really dying in any painful sense, but rather rearranging itself in response to a change deep inside. There is no moment of failure anywhere in the entire process. The star is doing exactly what the laws of physics require it to do, given a core that has finished one kind of fuel and not yet begun another. There is no struggle in it, no resistance, no failure. It is simply the next shape a star takes when the old shape no longer balances. Stars do not fight their endings. They flow into them smoothly as water finds a new level. The 99th fact is that from a great distance, the moment our sun turns red would be the only time in its entire life that anyone far away might notice it at all. For 10 billion years, it would be a faint and anonymous point among billions. Then, for a few 100 million years, it would flare into prominence, a warm, bright ember in some distant astronomer's sky, and then fade for good. If any eyes are watching from far away in that age, that will be the only chapter of our star's story they ever see. One brief red flourish, and then quiet. The 100th fact is that there is a real gentleness in imagining the red giant sun. Once you set aside the idea that bigger must mean more frightening, it would be the largest and softest and slowest thing anyone could possibly look at. Picture instead an immense, soft, deep orange light filling half the sky, glowing without glare, warm and slow and utterly silent, hanging above a still and empty world. It is the color of the last light of evening, held permanently. It is the hearth of the solar system, banked low and burning gently, and it will be like that for 100 million quiet years, long after everything we know has become a memory. The 101st fact is that whether the Earth will actually be swallowed by the red giant sun is one of the genuinely open questions in astronomy, and the answer hangs on a delicate balance. The sun will reach out to roughly the distance of our present orbit, which seems to settle the matter. But by then the sun will also have lost a good deal of its mass, and a lighter sun holds its planets less tightly. The Earth's orbit will widen as the star shrinks in weight, and the outcome depends on which of the two moves faster. The 102nd fact is that this widening of the orbit follows from one of the simplest rules in all of physics, that a planet circles according to the mass of the star holding it. It is the same rule that lets a spacecraft circle a small moon slowly and a great planet quickly. Take mass away from the sun and the planets drift outward, gently and automatically, into wider paths. As the aging sun sheds its substance into space, every world in the solar system will ease a little farther out, without anything pushing them. They will simply be held less tightly, and so they will loosen, every orbit relaxing very slowly as the star grows light. The 103rd fact is that the calculations of this race between a swelling star and a widening orbit come out extremely close, which is why astronomers still disagree about the answer. Some models find the Earth escaping by a narrow margin, drifting just beyond the reach of the expanding surface. Others find it caught by tidal drag and drawn inward at the last. The difference comes down to details of how much mass the sun loses and how quickly. It is a genuine coin flip written into the physics, and no one alive will ever learn the result. The 104th fact is that the tides may well decide it, because a swollen star raises a bulge on any nearby planet and that bulge drags on the orbit. These are calculations refined over decades, and they still sit almost exactly on the dividing line. The same interplay that has slowly pushed our moon away from the Earth can also work in reverse, pulling a planet inward toward a star whose surface is turning more slowly than the planet moves. Many careful studies suggest this tidal drag is just strong enough to bring the Earth home. The sun may not need to reach us at all. It may simply reel us gently in. The 105th fact is that if the Earth is drawn in, its ending will still be extraordinarily gradual, unfolding across many thousands of years. The planet would first begin to feel the thin outer gas of the star, and that faint resistance would slow it slightly, and a slower orbit is a smaller one, and a smaller orbit means thicker gas. Round and round it would spiral, deeper and warmer, until the rock itself softened and evaporated into the body of the star. Our world would not be destroyed so much as returned, every atom of it given back. The 106th fact is that either way, whether swallowed or spared, the Earth will long since have ceased to be anything like the world we know. Whatever it becomes, it will have stopped being a home a very long time before. By the time the sun begins to swell, our planet will have been dry and hot for billions of years, its oceans gone into the sky and then into space, its atmosphere thick and heavy, its surface bare rock beneath a permanent haze. The question of whether it survives the red giant is, in a sense, a question about a monument rather than a home, a stone marker either kept or gathered in. The 107th fact is that if the Earth does survive, it will find itself in a very strange new solar system, orbiting far out where Mars is today, circling a small white ember. The surviving planet would be a charred and airless ball, warmed by nothing, turning in near total darkness, illuminated only by a brilliant point no larger than a bright star. It would keep on circling faithfully for an almost unimaginable span of time. The Earth may well outlive the sun's fire by trillions of years, a quiet cinder, still keeping its appointment. The 108th fact is that the moon's own story ends long before any of this, and it ends by drifting away. We are, in that small sense, alive at the luckiest possible moment for looking upward. Our moon recedes from the Earth by about 4 centimeters every year, slowly stealing a little of the planet's rotation as it goes. In a few 100 million years, it will be far enough away that total eclipses become impossible, and the perfect coincidence of size that lets our moon exactly cover the sun will be over forever. We live in the one brief era when that alignment works, an accident of timing and a rather beautiful one. The 109th fact is that the outer planets will come through the red giant phase largely intact, and for them the change will be an improvement of sorts. Jupiter and Saturn, Uranus and Neptune, all of them lie far enough out to escape the swelling surface, and all of them will drift outward as the sun sheds mass. They will be bathed in a warmth they have never known, their frozen moons softening, their ice thawing into oceans and atmospheres. The outer solar system will have its one brief spring, millions of years of warmth at the very end. The 110th fact is that Titan, the great cloudy moon of Saturn, is often mentioned as the world that might have its moment in that era. It is one of the very few places in the solar system that gets better as the sun grows older. Today, it is a frozen place of methane rain and hydrocarbon lakes, far too cold for anything we would recognize as life. But under a red giant sun it would warm considerably, and its rich chemistry, already remarkably complex, would be stirred and quickened. Whatever happens there, it will happen in a warm orange light for billion years from now. A strange and distant possibility, worth a moment's gentle wondering. The 111th fact is that the sky of the far future Earth will hold nothing familiar in it. Quite apart from the sun, the constellations we know have already changed considerably across mere tens of thousands of years, and across billions they will be utterly rearranged. The Big Dipper long since scattered, Orion long since dispersed. Every pattern anyone has ever named will be gone. The stars of that sky will be stars not yet born tonight. A completely different night above a completely different world. The 112th fact is that the Milky Way itself will have changed by then, because our galaxy and Andromeda are drawing together and will meet in roughly 4 billion years. We will not so much travel to another galaxy as have one arrive around us. The two great spirals will pass through one another, their shapes stretched into long luminous streamers, and after a long dance they will settle into a single larger galaxy. The sun will most likely be flung into a wider orbit, farther out. Almost no stars will collide, for the spaces between them are far too great. It will be a merging of clouds, not a crash. The 113th fact is that this means our sun will very likely spend its red giant years in a galaxy that no longer exists in its present form. The graceful spiral arms will be gone, replaced by a great smooth elliptical swarm of aging stars. There will be no Milky Way arching across the night. In their final chapter, the Sun and Earth will belong to a different galaxy entirely, one that has no name yet, though astronomers sometimes call it Milkomeda. A new home, arrived at without ever moving from the spot. The 114th fact is that it is worth saying plainly that all of these changes lie so far ahead that the Earth we know will have had time to reinvent itself many times over first. The world of 5 billion years from now would be a stranger to the world of 1 billion, and both to ours. The continents will gather into a single supercontinent and split apart again perhaps a dozen times. Entire mountain ranges will rise and be worn flat into plains. Whole kingdoms of living things will appear, flourish, and be replaced. The Earth of 1 billion years from now would already be unrecognizable. And it is only a fifth of the way to the red giant. The 115th fact is that among everything we might mourn about that future, the loss of the oceans is perhaps the strangest to imagine, because they have been here almost from the beginning. Liquid water has covered most of this planet for something like 4 billion years, longer than there has been life on land, longer than there have been continents in their present shape. It is the oldest continuous feature of our world, and it will end quietly, in vapor, under a slightly brighter sun, an unimaginably long story, closing without a sound. The 116th fact is that if any trace of us survives to that age, it will most likely not be on the Earth at all, but on the moon or drifting between the stars. They will carry on drifting long after the star that launched them has stopped shining. Footprints in the lunar dust have no wind to erase them and may last for millions of years. The small spacecraft we have sent beyond the planets will still be coasting, cold and silent, long after our world is dry. The most durable things we have made are the ones we let go of, quietly traveling with nowhere in particular to be. The 117th fact is that thinking about the end of the earth tends to feel heavy only when we imagine it happening to us, and it is not going to happen to us. No person who has ever lived, and no person who ever will live in any span we can meaningfully picture, will experience any part of this. It is not a fate awaiting anyone. It is simply the shape of a very long story, most of which takes place in an empty theater, described from a great distance on a quiet night for the pleasure of knowing. The 118th fact is that the Earth has already survived a very great deal, which is worth remembering when its distant ending is described, and whatever survives on it, in whatever form, will have had billions of years of quiet in which to do so. It has been struck by objects that reshaped its entire surface, frozen over from pole to pole more than once, and had its atmosphere completely rewritten by the living things upon it. Each time, it settled and went on turning, and life continued in some new arrangement. This is an extraordinarily durable world. Whatever comes, it will have taken billions of years and the death of a star to change it, which is no small compliment. The 119th fact is that in the very long view, the matter of the Earth is not lost even if the planet is swallowed, because nothing in the universe is ever truly destroyed. The atoms of our rock and iron and water would be stirred into the outer envelope of the sun, and later cast into space when that envelope drifts away, and they would join the thin cold clouds between the stars. In some far age they might gather again into some new world around some new star, the same atoms on their next long assignment. The 120th fact is that every atom in the Earth and every atom in you has already been through such a cycle at least once before. The atoms are simply borrowed for a while and then returned and then borrowed again. The iron in your blood and the calcium in your bones were made inside stars that lived and died before the sun was born, and were scattered into the cloud from which our whole solar system formed. You are already made of recycled starlight. Whatever happens to this world in 5 billion years is simply the next turn of a wheel you are already riding, and it turns very, very slowly. The 121st fact is that all the while the sun is swelling into a red giant, its dead helium core is still contracting and still growing hotter, climbing toward a threshold. Helium nuclei carry twice the electric charge of hydrogen nuclei and repel one another far more strongly, and so they require a temperature of about 100 million Kelvin before they can be forced together at all. The core is climbing steadily toward that number. When it arrives, something entirely new will begin, a second fire of a different kind, in a star that had seemed to be finishing. The 122nd fact is that when the core does reach 100 million degrees, the helium ignites all at once, in an event astronomers call the helium flash. It is the one moment in the sun's entire existence that could fairly be called sudden. Because the core is degenerate, held up by quantum pressure rather than heat, it cannot expand to cool itself when the fusion begins. So the first reactions raise the temperature, and the higher temperature drives faster reactions, and for a few minutes the runaway is spectacular. It is the most sudden thing that will ever happen inside our star, and, remarkably, no one outside would see a thing. The 123rd fact is that during those few minutes, the core of the sun will briefly generate energy at a rate comparable to all the stars of a galaxy put together, and yet the surface will hardly change at all. Every bit of that colossal output is spent lifting the crushed core out of its degenerate state, pushing it apart, letting it expand and cool. The energy never reaches the outside. It is entirely absorbed by the vast envelope above. The most violent moment in the sun's life will be completely invisible, a great silent thunderclap, muffled by 100 million kilometers of gas. The 124th fact is that the helium flash happens only in stars of roughly the Sun's mass, and it is a consequence of that strange degenerate matter in the core. It is a small, private event, and the star handles it entirely on its own. Heavier stars have cores hot enough to begin helium fusion before degeneracy sets in, and for them the transition is smooth and gradual. Our Sun, being modest, must pass through the flash instead. It is one of the small distinctive features of being a star like ours, an abrupt little chapter that only middling stars ever have to read. The 125th fact is that the reaction which begins in that flash is called the triple alpha process, and it is one of the most improbable and important things that happens anywhere in nature. Two helium nuclei must first collide to form beryllium, a nucleus so unstable it falls apart almost instantly, and a third helium nucleus must strike it during that vanishing instant to make carbon. It should almost never work, but at such densities it works often enough, and every carbon atom in every living thing was made in exactly that way. The 126th fact is that the astronomer Fred Hoyle realized in the 1950s that this reaction could only work if the carbon nucleus had a particular energy level, and he predicted that level before anyone had measured it. Every carbon atom in your body is standing evidence that he was right. He reasoned simply that carbon exists and we exist, and therefore the universe must be arranged to allow it. The laboratories looked and found the level exactly where he said it would be. It remains one of the boldest and most successful predictions in the history of physics, reasoned backward from the fact of our own existence. The 127th fact is that once helium fusion is established, the Sun settles into a new and comparatively peaceful stage that astronomers call the horizontal branch. The core, no longer degenerate, now burns helium into carbon steadily, and around it a shell continues to fuse hydrogen. The star shrinks back considerably from its greatest red giant size and grows a little hotter at the surface. After the drama of the flash comes a long calm, a second middle age, briefer than the first but every bit as steady. The 128th fact is that this helium burning stage will last about 100 million years, which is a long time by any human measure and yet very short indeed for a star. A star burning helium is spending a smaller fortune much faster. Compared with the 10 billion years the Sun spent fusing hydrogen, it is roughly 1% as long. Helium is simply a poorer fuel, yielding far less energy for each gram consumed, and the star is burning it faster while shining more brightly. The second fire is fiercer and briefer. 100 million years of quiet, and then the fuel is gone again. The 129th fact is that during the horizontal branch, our Sun will be perhaps 50 times brighter than it is tonight, and roughly 10 times its present width. That is far smaller than it was at the tip of the red giant branch, and so this stage represents a genuine, if temporary, settling. The star pulls itself back in, steadies, and shines with a warm yellow-orange light. From outside, the Sun of that era would look like a modestly swollen version of itself, larger and brighter and calmer, holding its shape for 100 million years. The 130th fact is that horizontal branch stars are easy to identify in old star clusters, where they form a neat line stretching across the diagram, which is exactly how the stage got its name. You could photograph our Sun's future tonight in a cluster 12 billion years old with a large enough telescope. In globular clusters, those ancient balls of hundreds of thousands of stars that orbit our galaxy, the horizontal branch is one of the most striking features. Every one of those stars is doing what our Sun will do. The future of our star is plainly visible tonight, scattered through the halo of the Milky Way, in clusters older than the Earth. The 131st fact is that the carbon being made in the core during this stage is the same carbon that makes up nearly every living thing on Earth. Wood and sugar and the long chains of every protein in your body All of it is built on carbon that was made in the hearts of stars exactly like the one we are describing. Our sun will make its own carbon in that late chapter, though far too late for any use by anyone here. It will simply do what countless stars before it did, and add its share to the universe's supply. The 132nd fact is that alongside carbon, the helium-burning core also makes oxygen. When another helium nucleus strikes a newly formed carbon nucleus, those two elements are the quiet legacy of every star that ever reached this stage. And so the two elements that between them make up most of your body, and most of the Earth's crust, and all of the air you are breathing right now, come from this one stage in the life of ordinary stars. Carbon and oxygen are the twin gifts of dying middle-sized stars. Every breath you have ever taken has drawn on the leftovers of that process, made in stars that finished long before ours began. The 133rd fact is that during this period the sun will continue losing mass, though at a modest rate compared to what is coming later. The wind blowing from its surface will be considerably stronger than today, and by the end of the horizontal branch, the star will have shed a noticeable fraction of its substance. Each parcel of gas that leaves simply drifts outward, cooling, joining the thin material between the stars. The sun is beginning, quietly, to give itself away, a little at a time and without any sign of effort. The 134th fact is that some stars on the horizontal branch pulse rhythmically, swelling and shrinking with the regularity of a slow heartbeat, and those stars have been enormously useful to us. A star's pulse, measured carefully, can tell you how far away it is. They are called RR Lyrae variables, and because their true brightness can be worked out from the rhythm of their pulsing, they serve as measuring rods for distances across our galaxy. Stars in this stage of life have quietly helped us map the Milky Way, beating patiently in clusters far from home. The 135th fact is that the sun itself is not expected to pulse in that way, since only stars in a particular narrow band of temperature do so, and ours will pass just outside it. Our star will hold its brightness steady through its helium-burning years, as it has always done. Even in its late chapters, the sun keeps its habit of quiet reliability. There is something rather in character about that. 10 billion years of steadiness, and then, when everything is changing, still no flicker. A star that simply does not fuss. The 136th fact is that as the helium in the core is gradually converted into carbon and oxygen, the star approaches the same situation it faced once before, only one level deeper. Each turn of that pattern takes 1/100th of the time the one before it took. A center of inert ash with fusion continuing in shells above it. The pattern repeats. Fuel is exhausted, the core contracts and heats, the shells light, and the envelope swells again. Stars die in a kind of nested rhythm, each stage a smaller and faster echo of the last. A spiral of chapters, each shorter than the one before. The 137th fact is that our sun will stop after carbon and oxygen, because it will never grow hot enough to fuse them into anything heavier. Carbon fusion requires temperatures near 600 million degrees, and a core of the sun's modest mass simply cannot reach that. The star will build a carbon-oxygen center and then go no further, no matter what happens. That limit, set entirely by mass, is why our sun's ending will be so gentle. It will run out of possibilities long before it runs out of dignity. The 138th fact is that the whole sequence of stages, main sequence to subgiant to red giant to horizontal branch, was worked out over the 20th century by people who could never watch a single star change. It is one of the finest pieces of reasoning anyone has ever done with a single night's worth of data. Not one star has been observed to move from one stage to the next, because the changes take millions of years. Instead, astronomers looked at millions of stars at once, at every possible age, and pieced the story together like a family album full of strangers. It is a portrait assembled from a single frozen glance, and it has proved remarkably right. The 139th fact is that if there is a lesson in the helium flash, it is that even the most violent thing a star like ours can do is entirely swallowed by its own patience. A burst of energy briefly rivaling a galaxy, and it produces nothing at the surface but a very slow settling that takes 10,000 years to complete. The star simply absorbs its own upheaval. Whatever happens deep inside, the outside stays gentle, which is perhaps not a bad way for anything to handle its difficult moments. The 140th fact is that this stage, 100 million years of steady helium burning, is the sun's last long period of calm before the end of its story. Nothing in that solar system will change again for a very long while. 100 million years, roughly the span from the last dinosaurs to now, running twice over. All of it quiet, all of it steady, all of it in a solar system where the inner planets are gone and the outer ones have thawed. It is a strange kind of peace, and it is real peace nonetheless. A warm orange star shining calmly over a rearranged and silent house. The 141st fact is that when the helium in the core finally runs out, the sun begins its second great swelling, along what astronomers call the asymptotic giant branch. The name comes from the way such stars approach the red giant branch on the diagram from below, drawing near to it without quite touching, like a curve creeping toward a line it never reaches. In plain terms, the sun becomes a red giant for a second time, larger than before, and this time it will not come back. The 142nd fact is that the structure of an asymptotic giant star is remarkable, with two separate burning shells wrapped one inside the other around a dead center. Nearly all of its enormous volume contains almost none of its substance. At the middle sits a small dense sphere of carbon and oxygen, quiet and inert. Around it burns a shell of helium. Around that burns a shell of hydrogen. And around all of it swells an envelope so vast and thin it is barely there. The sun becomes a set of nested fires. A small hot heart wrapped in two rings of flame, inside an enormous cool haze. The 143rd fact is that these two shells do not burn steadily together, but take turns in a slow alternating rhythm called thermal pulsing. The hydrogen shell burns quietly for tens of thousands of years, dropping fresh helium onto the layer below, until that layer suddenly ignites in a brief flare that pushes the shells apart and puts the hydrogen fire out for a while. Then everything settles, and the cycle begins again. The star develops a very slow heartbeat, one beat every 100,000 years or so, for a very long time. The 144th fact is that each of those thermal pulses causes the whole star to swell and brighten and then relax again. And this is the most restless our sun will ever be. The star is learning, slowly, how to let go of itself. The outer envelope heaves outward with each pulse and settles back. And over many cycles the star gradually loosens its grip on its own outer layers. There will be perhaps a dozen or two of these pulses before the end. Each one is a slow, enormous breath, and each one lets a little more of the star escape into space. The 145th fact is that during these pulses the convection reaches so deep that material processed in the burning shells is carried all the way to the surface, in what is called the third dredge-up. Carbon made in the depths is lifted into the visible layers, and the star's own composition changes before our instruments. Some stars carry up so much carbon that their atmospheres become richer in carbon than in oxygen, and they turn a deep, striking ruby red. Those are the carbon stars, some of the reddest objects in the entire sky. The 146th fact is that asymptotic giant stars are the great manufacturers of about half the elements heavier than iron in the universe, through a slow and gentle process of neutron capture, Much of the gold in the world's jewelry was assembled that way, in the quiet interior of a dying star. Deep inside them, atomic nuclei absorbed neutrons one at a time, over thousands of years, gradually climbing the ladder of the periodic table. Barium, strontium, lead, and much of the world's silver and gold trace back to such stars. The heavy metals in the Earth's crust were built slowly, in the calm interiors of dying giants, one neutron at a time. The 147th fact is that as the Sun climbs the second giant branch, it will swell even larger than before, perhaps 200 times its present width or more at the peak of a pulse. Its brightness will reach several thousand times what it is tonight. It will be, briefly, the most luminous the Sun ever becomes in its entire existence. And it will be at its coolest and reddest and thinnest at the same time. The star reaches its greatest size at the very end of its life, enormous, faint-surfaced, and barely holding together. The 148th fact is that the surface gravity of such a star is so weak that its outer layers are only loosely attached, and the pressure of its own light is enough to push them away. It is the softest possible mechanism for taking a star apart. Dust grains condense in the cool upper atmosphere, and starlight strikes those grains and drives them outward, and they drag the surrounding gas along with them. This is how a star sheds itself. Light pushing on soot gently and steadily across millions of years, and slowly the envelope leaves. The 149th fact is that the wind blowing from an asymptotic giant is enormously stronger than anything the Sun manages today, carrying away as much mass in a single year as our present star loses in 100,000. These are called super winds, though the word suggests far more violence than there really is. The gas leaves at only a few kilometers per second, slower than a rocket, drifting rather than rushing. It is not a gale. It is an exhalation, vast, cool, and unhurried. The 150th fact is that across this stage, the Sun will lose close to half of its total mass, which is by far the most dramatic change of its entire existence. The Sun will simply be half as heavy as it was, and the difference will be scattered across a few light-years of space. Everything the star has ever been made of, apart from the small dense core, will drift away into the space around it, atom by atom across a few 100,000 years. The Sun will simply disperse most of itself into the galaxy. There is no explosion in it, no violence, no rupture, only a very great letting go. The 151st fact is that all of that material, once it drifts away, becomes part of the thin cold clouds between the stars, where new stars are eventually born. The carbon and oxygen the Sun made, and the heavier elements built one neutron at a time, will mingle with the gas of the galaxy and enrich it. Some far future cloud will collapse and light a new star, and that star will hold a little of ours. The Sun scatters its inheritance widely, and it will be spent on children it never meets. The 152nd fact is that this is precisely how our own Sun came to hold the elements it does, and how the Earth came to be made of rock and metal rather than only hydrogen. The Sun is not doing anything unusual. It is repaying a debt that every star before it also repaid. The cloud that formed our solar system had already been seasoned by generations of dying stars, each of them going through exactly this process. Every heavy atom on this planet arrived that way. When we describe the Sun scattering its substance, we are describing the same act that made our world possible. Simply run once more, 5 billion years later. The 153rd fact is that we can watch these dying stars right now, and they are among the most photographed objects in astronomy. Mira, in the constellation Cetus, is an asymptotic giant star that swells and fades over about 11 months, disappearing from naked eye view and then returning. It has been watched for 400 years. It even leaves a long tail of shed material behind it as it moves through space. Our sun's late chapters are on display tonight, written across the sky in slow variable light. The 154th fact is that the material leaving these stars quickly cools and forms dust. Real solid grains of carbon and silicate, tiny motes of soot and sand drifting into the dark. Some of the grains in the oldest meteorites came from stars that died before the sun was born, and we can still tell which. Much of the dust in our galaxy was made this way, in the cooling winds of dying stars. That dust darkens the Milky Way, seeds new clouds, and eventually gathers into the rocky cores of planets. The soot from an old star becomes the ground beneath someone's feet, given enough time and enough patience. The 155th fact is that as the envelope departs, layer after layer, the hot inner regions of the star are gradually uncovered, like a lantern being unwrapped. What had been buried under 1,000,000 kilometers of gas comes closer and closer to the surface, and the temperature of the exposed layer climbs steadily. A star that was a cool red giant begins to grow hotter and bluer, not because anything inside has changed, but because we are seeing deeper into it, peeling back toward the ember at the center. The 156th fact is that the transition from red giant to naked core is astonishingly fast by stellar standards, taking perhaps only a few tens of thousands of years, and through all of it the star grows quieter, not louder. After 10 billion years of steady life, the final unwrapping of the sun happens in less time than has passed since the last ice age. It is the one genuinely quick chapter in the whole story. And even so, it would be far too slow for anyone to watch and utterly silent. A lifetime's worth of change spread across a few hundred human generations. The 157th fact is that once the envelope is gone, the fusion shells run out of fuel to burn and finally fall quiet for good. The last of the hydrogen and helium available to them is either consumed or carried away, and the reactions that have lit our star for more than 10 billion years simply stop. There is no final flare and no last gasp. The shells thin, cool, and cease. After that, nothing inside the sun will ever fuse again. The fire, having nowhere left to go, goes out. The 158th fact is that what remains at that moment is the naked core, a sphere of carbon and oxygen roughly the size of the Earth, holding about half the mass the sun has today. Everything it will ever give the universe it has already made. It is still glowing ferociously at 100,000 degrees or more, purely from the heat left over inside it. But it is making nothing new. Every particle of light it will ever release is already stored within it. It is an ember lifted out of a fire that has just gone out, brilliant and finished. The 159th fact is that the timing of all this deserves a moment's thought, because the entire dramatic portion of the sun's life, from the first swelling to the last exposed core, occupies well under 1 billion years, 10 billion years of quiet, and then perhaps 700 or 800 million of change. Even the star's ending is mostly patience. And then, after the change is complete, comes the longest chapter of all, far longer than everything that went before it. The chapter in which nothing happens at all forever. The 160th fact is that there is a real tenderness in the way a star like ours ends. Once you see the whole shape of it, nothing about it is tragic once the whole shape is visible at once. It does not tear itself apart. It does not collapse or detonate or vanish. It simply gives away nearly everything it has, slowly, over hundreds of thousands of years, until only its warm heart is left, and then it cools. Half of the sun will drift out into the galaxy to become other things. The rest will rest quietly where it is, which is, in its way, a rather generous ending. The 161st fact is that when the hot bare core is finally uncovered, Its fierce ultraviolet light floods into the cloud of gas the star has just released, and that cloud begins to glow. The shed envelope, drifting outward for thousands of years, is suddenly lit from within. What had been dark and invisible becomes a luminous shell of color. This glowing object is called a planetary nebula, and it is the last visible thing our sun will ever make. A soft, bright wreath, hung around a fading ember. The 162nd fact is that the name planetary nebula is one of the great misnomers in astronomy, and it has nothing whatever to do with planets. They are perhaps the loveliest objects that anyone can see through a small telescope. William Herschel coined it in the 1700s because in his telescope these objects appeared as small round bluish disks, resembling the newly discovered planet Uranus. The name stuck long after everyone understood what they really were. Astronomy is full of such inherited words. We still call them planetary nebulae, a 200-year-old mistake, kept out of habit and affection. The 163rd fact is that a planetary nebula glows for only about 10 to 20,000 years before it fades away, which makes it one of the briefest things in all of astronomy. The gas keeps drifting outward, growing thinner and dimmer, until at last it disperses into the general medium between the stars and can no longer be seen at all. 20,000 years is nothing to a star. It is a candle lit at the end of a very long evening, beautiful, and gone almost as soon as it begins. The 164th fact is that because the phase is so short, only about 3,000 planetary nebulae are known in our entire galaxy, though a great many stars must pass through the stage. Each one has been glowing for less time than there have been cities on the Earth. At any given moment, very few stars happen to be in that fleeting window. Everyone we see is a star that finished dying only a few thousand years ago, in cosmic terms just now. Each of them is a snapshot of an ending in progress, and every one of them is a portrait of our own sun's last visible act. The 165th fact is that the colors of a planetary nebula come from particular atoms glowing at particular wavelengths, and they are among the purest colors in nature. The deep green teal that dominates so many of them comes from doubly ionized oxygen. The reds come from hydrogen and nitrogen. The blues from helium. Each element gives off its own exact shade, unmixed and unmuddied. What you see in a photograph of such a nebula is chemistry rendered directly as color, a glowing inventory of everything the star made. The 166th fact is that these objects come in an astonishing variety of shapes, and almost none of them are simple spheres, which surprised astronomers for a long time. A photograph of a dozen of them side by side looks like a collection of glass ornaments. There are hourglasses and rings, butterflies and spirals, delicate nested shells and long twin jets. The ring nebula in Lyra is a perfect luminous smoke ring. The cat's eye is a nest of layered bubbles. The helix looks like an enormous eye in the dark. Every dying star seems to make something different, and no one knows exactly why. The 167th fact is that a good part of the answer probably lies in companions, since many stars are not alone and a nearby partner can shape the outflowing gas. A second star, or even a large planet, orbiting within the expanding envelope can stir it into a disk, or funnel it into two opposite lobes, or wind it into a spiral. The beautiful shapes may be the fingerprints of unseen companions. Our sun, having no stellar partner, will probably make something simpler, a rounder, quieter, more modest ring. The 168th fact is that the nebula our sun makes will be quite faint by the standards of the ones we photograph, because our star is on the lighter end of the range that produces them. Not every star's ending is spectacular, and there is nothing at all wrong with that. A less massive core is cooler and gives off less ultraviolet light, and so it lights its cloud less brilliantly. Some astronomers think the Sun will produce only a very dim and short-lived nebula, or possibly none worth speaking of at all. Even at the very end, our star will do things gently, a soft glow rather than a display. The 169th fact is that the expanding shell moves outward at only a few tens of kilometers per second, which is slow enough that we can actually watch some nebulae grow from year to year. Careful photographs taken decades apart show the rings quietly widening. It is one of the few places in astronomy where change is visible within a human career. Even so, the motion is the drifting kind, not the rushing kind. The Sun will release its outer layers at about the speed of a small meteor, which is to say, gently. The 170th fact is that this is the moment when the elements a star has made are finally handed back to the galaxy, and planetary nebulae are responsible for a great deal of the carbon and nitrogen in the universe. A cloud that will one day form a star already carries the gifts of thousands of stars before it. Every cloud that will ever form new stars is a little richer for each one of these. Our Sun's contribution will drift outward for tens of thousands of years and then mingle with the interstellar gas. Whatever it made in its long life, it gives away completely at the end. Nothing kept back except the core. The 171st fact is that the Sun will never, under any circumstances, become a supernova, and this is one of the most reassuring facts in all of astronomy. A supernova requires a star of at least about 8 times the Sun's mass, and our star falls very far short of that threshold. It is not close. It is not borderline. There is no possible sequence of events in which our Sun explodes. The most violent ending in the cosmos is simply not available to it, and never was from the day it formed. The 172nd fact is that the reason for that limit comes down to what a core can be persuaded to do under pressure. Our star lacks the weight to ever build anything that heavy, and so the door is simply closed. Only a sufficiently massive star can compress its center hot enough to fuse carbon, and then neon and oxygen and silicon each stage faster than the last, until it builds an iron core that can yield no further energy at all. When that iron core collapses, the star explodes. Our Sun will stop at carbon and oxygen and go no further, and so it will simply never have anything to collapse. The 173rd fact is that this 8 solar mass threshold means that the overwhelming majority of all the stars in the universe end exactly as our Sun will quietly. Massive stars are rare, perhaps 1 in 1,000, and they live only a few million years. The vast bulk of stars are small and modest, and every one of them will fade into a white dwarf without any explosion whatever. Supernovae are the exception, not the rule. The ordinary fate of a star is a slow cooling ember, and ours will share it. The 174th fact is that even if a star did explode somewhere in our neighborhood, the distances involved make it a far gentler prospect than it sounds. We are, on every count, in a very safe part of a very safe neighborhood. A supernova would need to be within roughly 50 light-years to affect the Earth meaningfully, and no star capable of exploding lies anywhere near that close. Betelgeuse, the great red shoulder of Orion, will certainly explode one day, and it is 600 light-years away. When it does, it will be a beautiful bright star, visible in daylight, and completely harmless. The 175th fact is that in some ways the quiet ending is the more generous one, because a star like ours returns its material to the galaxy slowly and coolly rather than blasting it away. The gas from a planetary nebula drifts out at modest speed and mingles easily with the surrounding clouds, ready to be gathered into new stars. Supernova debris is flung out so violently that much of it is scattered across enormous distances. Gentle endings make good soil, and the galaxy is fed by both. The 176th fact is that the naked core sitting at the heart of the nebula is astonishingly hot in that brief moment. often more than 100,000 degrees. And it is that ferocity that lights the whole display. It is the last work our star will ever do with the heat it spent 10 billion years making. The core has been buried under the entire body of the star for billions of years, holding heat, and now it stands exposed. Its light is almost entirely ultraviolet, invisible to our eyes, and it is the gas that turns that invisible energy into the colors we see. A fire we cannot see, made visible by what it touches. The 177th fact is that the nebula and its central star will part company quite quickly, and the ending has a certain quiet grace to it. The shell keeps drifting outward and thinning while the core keeps cooling and dimming, until the ultraviolet light is no longer strong enough to make the gas glow. The colors fade one element at a time. The ring grows faint and wide and finally invisible. The star lets go of its own light, and after that there is only the small hot point, alone in the dark. The 178th fact is that if anyone were watching from a great distance, the whole visible ending of our sun would seem to happen in an instant compared with everything before it, and then follows an emptiness so long that all of the above becomes a rounding error. 10 billion years of steady yellow light, then a few 100 million of swelling and reddening, then 20,000 years of a glowing colored ring, and then nothing but a fading white point. The last act is by far the shortest and the most beautiful. Everything memorable about our star's death takes less time than the history of agriculture. And then it is over. The 179th fact is that the Ring Nebula, which you can see through a modest telescope on a summer night in the constellation Lyra, is very nearly a portrait of our own future. It is a soft gray-green smoke ring about 2,000 light-years away, with a faint blue star at its center, and it has been glowing for perhaps 7,000 years. Someone with a small telescope in their garden tonight can look directly at the sort of thing our sun will one day become: a quiet ring and a small hot point. The 180th fact is that there is something worth resting on in the thought that the last thing our star ever does with its light is to make something beautiful out of what it has released. It is one of the few beautiful things in the universe that requires no witness at all. For 20,000 years, the sun's cast-off body will glow in soft greens and reds around a small, brilliant center, drifting outward, thinning, fading. No one may ever see it. It will happen anyway, exactly as it has happened around countless stars before. The universe makes such things constantly without any audience, simply because that is what happens when a star lets go. The 181st fact is that what our sun becomes at the end of everything is called a white dwarf, and it is one of the strangest and most peaceful objects in the universe. It is a sphere of carbon and oxygen holding roughly half the sun's present mass, compressed into a volume no larger than the Earth. It makes no energy of any kind. It simply glows with the heat it has kept, and cools and goes on cooling. The sun's final form is not a fire at all. It is a memory of one. The 182nd fact is that the density of such an object is difficult to hold in the mind. For a single teaspoon of white dwarf material would weigh several tons here on Earth, and yet it holds its shape perfectly and will hold it essentially forever. The whole mass of half a sun is packed into a ball the size of our planet, which means the matter inside is compressed hundreds of thousands of times more tightly than anything we know. It is not made of ordinary atoms in any ordinary arrangement. It is something entirely else, a substance that only exists where gravity has had the last word. The 183rd fact is that what holds a white dwarf up, now that no fusion remains to push outward, is a purely quantum effect called electron degeneracy pressure. The electrons within it are packed so closely that a fundamental rule forbids any two of them from occupying the same state, and that rule alone resists further compression. It is not heat that keeps the star from collapsing. It is a law about how the very small must be arranged. The sun will spend eternity held up by a principle, rather than by a fire. The 184th fact is that because of this, a white dwarf behaves in a way that feels backward, for the more massive one is, the smaller it becomes. Nothing our sun does could ever bring it anywhere near that boundary. Adding mass compresses it further rather than making it bigger. And there is a hard ceiling to how much such a star can hold, about 1.4 times the mass of our sun, a limit worked out by Subramanian Chandrasekhar while he was still a young man on a long voyage by ship. Beyond that limit, no white dwarf can exist, but ours will sit comfortably at less than half of it. The 185th fact is that when our sun's core is first laid bare, it will be extraordinarily hot, something close to 100,000 Kelvin at the surface, far hotter than the sun has ever been in all its history. It will shine with a fierce blue-white light, small and brilliant, a point of intense brightness in the middle of its fading nebula. This is the hottest our star will ever be, and it happens after the fire has already gone out. A last blaze of stored warmth with nothing behind it. The 186th fact is that the cooling of a white dwarf begins quickly and then slows enormously, in the way any hot object cools when it has nothing left to replace what it loses. It is the longest cooling of anything, anywhere. In the first few million years, it will drop rapidly from 100,000 degrees down to perhaps 20,000. After that, each further stage takes far longer than the one before. The star has an enormous store of heat and a very small surface through which to release it, and so it lets go with extraordinary reluctance. The 187th fact is that from white-hot the sun's remnant will pass slowly through blue-white, and then a soft yellow, and then orange, and finally a deep dim red over billions upon billions of years. It will walk backward down the same ladder of colors that any cooling ember walks. The whole span of recorded human history would not be enough to notice a single shade of the change. It will simply drift one color at a time toward the dark, taking longer at every step. The 188th fact is that a white dwarf as small as the Earth and as bright as a candle in a distant window is remarkably hard to see, and yet we have found many thousands of them. Its light is roughly 10,000 times fainter than the star beside it, which is why it took a mathematician to notice it first. The nearest is Sirius B, the faint companion of the brightest star in our night sky, only about 8.5 light-years away. It was discovered because it tugged its bright partner slightly off a straight path. There is a dead star hiding in the glare of the brightest star we know, quiet, tiny, and unimaginably dense. The 189th fact is that white dwarfs are, in a real sense, the most common ending in the universe, and the galaxy is full of them already. Astronomers estimate there are hundreds of billions of white dwarfs scattered through the Milky Way, each one the cooled heart of a star that finished long ago. They drift among the living stars, dark and unnoticed, keeping the same orbits they always had. The galaxy is not only full of stars, it is full of the small, quiet remains of stars, more of them with every passing age. The 190th fact is that as a white dwarf cools past a certain point, the carbon and oxygen inside it are thought to arrange themselves into an ordered lattice, in a process very much like freezing. It is the largest crystal that will ever exist anywhere. The interior becomes a crystal, a single vast structure of ordered nuclei held in place. Astronomers have found evidence of exactly this in the cooling patterns of nearby white dwarfs. The sun's remnant will one day be a crystallized sphere the size of the Earth. A still, cold, perfectly ordered thing, turning quietly in the dark. The 191st fact is that in the very far future, after enough time has passed, a white dwarf cools so far that it no longer gives off any visible light at all, and becomes what is called a black dwarf, It is a cold, dark sphere, the same size as before, holding the same mass, simply no longer glowing. And here is the remarkable thing, for the universe is not yet old enough for a single one to exist. Not one has ever formed anywhere. The first black dwarfs are still trillions of years away, and the cosmos has not yet had time to make one. The 192nd fact is that the cooling of a white dwarf into complete darkness is thought to take something on the order of 1 trillion years, and possibly far longer still. Nothing in the universe has yet had time to finish this last chapter. That is roughly 100 times the present age of the universe. Everything that has ever happened, from the very beginning to this evening, is barely the first day of that long cooling. The sun's ending is not an event at some future date. It is a fading so gradual that the universe itself is still far too young to have witnessed one anywhere. An ending with no last moment. The 193rd fact is that through all of that unimaginable span, whatever planets survive will still be circling, faithfully, keeping their orbits around an object that gives them nothing at all. The outer worlds and any surviving inner ones will turn slowly around a dim point, marking out years that no one counts, in a darkness that deepens by imperceptible degrees. Astronomers have already found rocky debris falling onto white dwarfs elsewhere, proof that planets do outlast their stars. Solar systems go on long after the light does, quietly and without complaint. The 194th fact is that a white dwarf makes no sound, produces nothing, changes almost not at all, and asks nothing of the universe around it. It is the closest thing the universe has to true rest. It simply exists, holding a small store of ancient warmth and releasing it a little at a time, for spans that dwarf every other process we know of. It is perhaps the most restful object in all of astronomy. Nothing troubles it. Nothing hurries it. Nothing at all will ever happen to it again. And it will be like that for very nearly forever. The 195th fact is that the whole story we have followed tonight is written in one simple number, the mass of the sun, and everything else has merely unfolded from it. How long it burns, how brightly, how far it swells, what it makes, how it ends, and what it leaves behind. All of it was settled in the moment a cold cloud finished collapsing 4.5 billion years ago. There is a strange peace in that. Nothing about our star's future is undecided. It has always been on its way to exactly this. The 196th fact is that, in a certain way, the sun does not really die at all, but is slowly redistributed, half of it into the galaxy and half of it into a small enduring ember. Almost every atom in existence has already been part of several stars, and is simply between assignments. Nothing is lost, nothing is destroyed, nothing simply ceases. The atoms scatter and are gathered again into other clouds, other stars, other worlds, perhaps other creatures who will look up at their own sky and wonder. The sun becomes many things instead of one, and some of those things may be alive in an age we cannot imagine. The 197th fact is that perhaps the gentlest thing about all of this is how completely it removes any sense of urgency from the night around you. Everything we have described lies billions of years ahead, arranged in advance, requiring nothing whatever from anyone. There is no action to take, no problem to solve, no decision waiting. The sun will do all of it slowly and correctly without any help. To know the whole shape of the future and to have no part to play in it is a remarkably restful kind of knowledge. The 198th fact is that between here and any of it lie 5 billion more mornings of the ordinary sun, unchanged, rising over an ordinary world. There is nothing at all in the sky that needs your attention tonight. The light that will wake you tomorrow is the same light that woke every generation before you, and it will be the same for an almost endless procession of days to come. Nothing about tonight sits anywhere near the edge of that story. You are resting in the long, warm, steady middle of it, in the calmest stretch of the calmest chapter, with everything ahead still waiting. The 199th fact is that as your thoughts grow soft and loose, you might let yourself drift forward through all of it at once, the way one drifts in a dream. Past the slow brightening and the boiling seas, past the swelling amber star and the silent absorbed planets, past the great red giant hanging enormous and quiet over an empty world, past the glowing colored ring drifting outward into the dark, and out into the long, still age of the small white ember, cooling gently, unhurried, alone and entirely at peace. There is no fear anywhere along that road, only time and quiet and warmth slowly letting go. The 200th fact is that long after this night, and long after all our nights, the small white heart of our sun will still be there, glowing faintly in the dark, holding the last of a warmth that once made oceans and forests and every morning anyone ever woke to, cooling so slowly that the universe itself has not yet lived long enough to watch such a thing finish. So let your breathing go soft, and let the day dissolve behind you, and drift out into that endless patient dark where nothing is ever hurried and nothing is ever lost. Rest now, sleep well, and thank you for drifting with me beyond the stars.